Measures of variation, section 2.4. So the objectives of this is to determine the range of a data set, determine the variance and standard deviation, and use the empirical rule to interpret standard deviation. The range is the difference between the max and the min data entries in the set. The data must be quantitative, and to find the range, we would take each max data entry and subtract each minimum data entry. Not each, just the max data entry and the minimum data entry. So for an example here, a corporation hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries. So in this instance, it'd be easier if we ordered our data from 37 to 47. Then we take our max data entry, 47, and subtract our minimum, 37. That would give us a range of 10. And that means the range of starting salaries is 10 if we put in thousands beside it, or 10,000 if you use it in the context of the problem. So, deviation, variance, and standard deviation. Deviation is the difference between the data entry x and the mean of the data set x minus mu. We will not find this much, but it's important to know. Variance is defined as the average of the squared deviations from the mean. And there is the formula for population variance, and I'll distinguish between those a little bit later. And then here's standard deviation, which shows how much variation or dispersion exists from the average, mean, or expected value. And then here is standard deviation of a population. And again, I will discuss population and sample in a little bit. So in Excel, if we want to find the variance or the standard deviation, this is the formulas we use. If we're having a population as our sample, then we're going to use var.p. If we are using a sample, then we're going to use var.s. And this insert data really just means to put the data in there. You can either highlight the cells, you can type the cells in, like A1 colon, I don't know, A9, or you could type each individual data entry separated by a comma. And then standard deviation, here's the population variance code, which is stdev.p. Then again, insert the data the exact same way I just discussed. And the sample, this should be population standard deviation and sample standard deviation, which insert the data just as I had shown before. Finding the population and standard deviation and variance. A corporation hired 10 graduates. The starting salaries for each graduate are shown again. So, if we want to find the population variance, we can plug it into the formula, and then there's a population standard deviation, or we're going to use Excel in our class. So I'm going to go over here to Excel and find the population variance. What I need to do is I need to click on the function wizard, and I need to type in var.p, and then choose that one below. Once I choose that one, I'm going to insert my data. I personally am going to highlight my data from A2 to A11, and then I'm going to hit enter. And it's going to give me the exact same thing we would have found, or very similar to the same thing that we would have found with our formula. There's a little bit of rounding errors, so it's a little bit different. In this case, we have 8.85, and they had already rounded it to 8.9. So population standard deviation, I'm going to type in the code for that one, which is stdev.p, and I'm going to hit enter and choose it. And then again, I'm going to highlight my data from A2 to A11 and hit enter. And I get the population standard deviation to be 2.97, about 5, which is very similar to what we got over here. They just rounded it to 3. Now, what if we are going to find the sample standard deviation instead of the population? Well, then again, we can use the formulas, and the only thing that changes in the formulas is the notation. As you can notice back here, in population variance, we have sigma squared, and we have it divided by n being the number of people. And then for the standard deviation, you take the square root. And it is also notated as just a sigma. If we look at this one, it is now s squared divided by n minus 1. And then we can take the square root again, but it is an s. So for a sample, we represent sample variance with s squared, sample standard deviation with s. But for the population, we use sigma squared and sigma for the two terms. So if we want to find this in Excel, we go back to Excel, and this time I'm just going to use a different formula. That's the only thing that changes. So sample variance is var.s. And then if I put equals in front of that, I don't have to worry about my function wizard anymore. So I'm going to put equal var.s and then comma. I can highlight my data and then enter, and I'm going to get my sample variance. Notice that these are different, and they should be different because the formula changes on the bottom from a capital N over here to an N minus 1. And now if I want to do my sample standard deviation, I do equal STDEV dot S, parentheses, highlight my data, close parentheses, and there I have my sample standard deviation. Now, I'm going to continue with the PowerPoint, and we're going to talk about standard deviation and how to interpret it. So, standard deviation is a measure of a typical amount an entry deviates from the mean. I've already discussed that with you. The more entries are spread out, the greater the standard deviation. So, as you notice with this one isn't spread out at all. Everything is right in the middle, and there's no deviation of the middle. So, its standard deviation is 0. As we spread out a little bit, we get a little bit of a standard deviation, a 1.2. But as we continue to spread out, we get a greater standard deviation as 3. So the wider our data values appear on our graph, the larger the standard deviation. Now, one thing we're going to talk about in interpreting standard deviation is the empirical rule. Now, the most important part here is this can be used with a symmetric bell-shaped distribution. And if that is so, then the standard deviation has the following characteristics. About 68% of the data lie within 1 standard deviation of the mean. Within 2 lies 95% of the data, and within 3 lies 99.7% of the data. So if we go to graph this, we'll notice that 68% of the data lies within 1 standard deviation. And that is what this represents, because remember, for sample, mean is x bar, and so this is x bar plus s, which is mean plus standard deviation, and over here mean minus standard deviation. And 68% lie within that. If we go out one more standard deviation, we get 95%, and if we go out even one more, we get 99.7%. So we can notice I've put the percents in each of these categories here, because if I fill in this bottom with a certain problem, I can calculate the percent of people within that by using these percents. Between 1 standard deviation to the left and the mean is 34%, 68 divided by 2. And then if I take 95, subtract 68, divided by 2, I get these, and so on and so forth for the 99.7. So here we have a certain problem. In a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States was 64 inches, with a sample standard deviation of 2.7. So what I'm going to do is I'm going to create my empirical rule by filling in the bottom. So 64 was my mean, and 2.71 was my inches. So I'm going to add 2.71 right here, and I'm going to subtract 2.71 right here to get within 1 standard deviation of the mean. And then I'm going to continue. I'm going to add another one to get 2 standard deviations to the mean to the right, and then I'm going to add another one to get 3 standard deviations to the mean to the right. And I will do the exact same thing to formulate the left side of this empirical rule. So if I wanted to know the women between 64 and 69.42 inches, which would be here the mean and 2 standard deviations on the positive side, I would simply add up 34 and 13.5 and get 47.5% of the women. Now, if I wanted to know a certain amount, let's say there's 100 people in the study, well then that would be an easy calculation. This times 100 gives me 47.5. But we can't leave it as 0.5 because we are dealing with women. And women, we cannot have 0.5 of a human, so we would have to say 48, and so on and so forth. So we have just covered range, variation, standard deviation, and the use of the empirical rule.